Okay. Hello everyone. Happy weekend. So today we're going to have our fourth Women in Tech webinar. Women in Tech webinar aims to showcase women who are leaders in their field and primarily uses Google Cloud Platform for in their work or in their personal projects. So for today's speaker, we have Pradhipa, who is a senior software engineer. She has no idea that she will be a developer while she graduated. She stumbled upon it, and now she doesn't stop talking about it. She likes to experiment and explore new technologies and aspires to be a developer advocate. So when not working, she likes to read and be found on tweet and can be found on Twitter and Medium at Pradita. So without further ado, I'm going to share Pradita's screen right now.
Hey everyone, I'm Pradeepa. Hi, thanks for joining the session. Um, Hope you guys can hear me okay. So let me get started. So this is an introductory session about OAuth 2.0 and OpenID Connect. Uh, don't get overwhelmed by these abbreviations. I'm sure we have all used applications using these standards. So I'm just give you an introduction to this protocols. Often these protocols are overlooked by developers, leaving the application they are developing vulnerable. So we'll just look at what are all the intricacies of these protocol, and then we'll look into what this means for different kinds of applications. Um, about me, I'm Pradeepa. I'm a senior software engineer. I'm also an Auth0 ambassador. Auth0 is a platform which operates in the authentication and authorization platform. So I'm an ambassador there, and you can follow me on Twitter, and this is my Medium blog. So let's look at the agenda for today. Let's look at first what is an Auth 2.0 mean, and we'll see what problem does OAuth 2.0 solves. We'll look at what are all the different roles involved in OAuth 2.0. I'll define what is a grant type mean and what is the different types of grant type or the recommended grant types for different kinds of applications. Um, OpenID Connect is built on top of OAuth 2.0. So most of the concepts will be covered in the previous topics. So we'll just see what is OpenID Connect and how does it fit into this OAuth 2.0 platform. We'll also define what's the scope and flows of OpenID Connect. So let's get started. Uh, I'll just set the stage of what is OAuth 2.0 and OpenID mean before heading into what is OAuth 2.0 separately. See, so we all know that OAuth 2.0 and OpenID Connect are both standards. They are not a separate service or any API. They set the standard for authentication and authorization. So OpenID Connect is the standard for authentication, and OAuth 2.0 provides a standard for authorization. Often people get confused between authentication and authorization. So let me just give you an example. Let's say I go to my friend's home, I knock at her door, and then she opens the door. She identifies me, and then she lets me in. If it's a stranger, the response would have been different. So that is authentication. So I've been identified, and then I was let inside the home. But once I enter the home, I may not have privileges or access to all the places inside the home, or I cannot access her laptop or a mobile phone. Those are all personal access of my friend. So I may not have provision to, I mean, I'm not have the privilege to access those things. So that's authorization. Identification is basically identifying yourself is authentication, and OpenID Connect defines a standard for that. And authorization is like, can I perform this function? So OAuth 2.0 defines the standard for it. Um, in terms of software applications, let's say in OpenID Connect terms, let's say you go to a website and then you click on sign in with Google. Basically, you're identifying yourself. So you go to the Google account, Google website, you give your credentials, and then your profile information will be shared to the application. This is a very common in any e-commerce application or any of your blogs, if you would have seen. So basically this is what, so user will request access to the application. Then application ask you to identify yourself. Either the identity can be managed here, like sometimes you don't have a sign in with Google, right? They manage their own credentials. But if you're looking for a different identity provider to share the credentials, then that is OpenID Connect. So let's say I have signed in with Google, and then what the application does is like it will redirect you back to the identity provider. So user will ask like, hey, share the identity information of me to this application. So that is OpenID Connect. Whereas in OAuth 2.0, we might have seen applications where we wanted to schedule a tweet on our behalf or post in Facebook walls on our behalf. So basically, we're asking the application to act on behalf of us. So let's say this the Twitter user, and then it's like there's a tweet scheduler app. So normally, what it does is like the user will grant some authorization in some form, and then this scheduler will get some authorization, and then it calls the Twitter API, and then either post a tweet or gets a Twitter timeline. So we'll see in specifics about what is OAuth 2.0. Um, so what is the actual problem that OAuth 2.0 resolves? So it's not long ago, at least a decade back, we have never seen applications like sharing between these applications. So if they wanted to share data between applications, this is what happened. So what happens is like Yelp, when you register with Yelp, so Yelp is asking, saying that, hey, you might have friends over here. Do you want to invite your friends? If yes, can you give me your Gmail ID and password so I can go to your Google contacts, get the contacts, and then send an email? Um, okay, this looks like a genuine use case. This is fine, but do I want to share my email address and password with Yelp? What happens, they send an email which I didn't authorize them to do, because I'm just literally sharing my email ID and password. And my Gmail is connected to my drive. All my credit card statements are going into my Gmail. I have my GPay account. So I can't trust Help to that level to share my access, or to give the key to the my own digital kingdom. So what I can do is, if there is a provision for me just to grant only specific access, let's say get only the contacts and send email, but also only during this time, like only when I know that this is happening. So that looks like a specific that solves the problem, right? So that's what OAuth 2.0 does. So let's see what is an OAuth 2.0 mean. This is an industry standard protocol for authorization. So this enables to share data between two different applications, so that you can share authorization across different type of applications without necessarily sharing your long-term credentials like password. And also, if we don't want, we can always revoke the session. So let me show you an example. um, let's say I have buffer.com. Let me log in. So this is basically a tweet schedule app. uh, just to show, I'll remove the connection. Okay. Okay. So now what I'm going to do, like I'm going to schedule my Twitter app with the buffer, so that I can schedule my tweet. So let's say I'm adding a new channel. So here I'm clicking on Twitter to add channel. Um, so what happens is I'm redirected from buffer.com to api.twitter.com. So the credentials that are being asked is only Twitter. I'm not sharing my password with Twitter. But what Twitter says to me is like, hey, there is an application called Buffer. It says that it wanted to schedule tweet on your behalf. So it can read and post, delete tweet. It can see your profile information. So do you want me to authorize this application? I said, okay, yeah, I'm the one who initiated this. So let me authorize it. So once I am back, I'm redirected to Buffer site. So this is a typical user journey. So I'm authorizing Twitter to grant this buffer access. So I can just schedule a Twitter. So I can schedule a tweet, and then it will just appear in my Twitter timeline. So what happened behind the scenes? There was some handshake between that's happening between Twitter as authorizing platform versus Buffer. So let's see the developer journey, how it would have happened. So before we start with the developer journey, we need to define some roles. So what is a resource owner? Resource owner is me, because I own the credentials and I'm approving the authorization. So resource owner does not necessarily have to be a physical user. It can be, if it is a machine to machine application, then it can be a server. Uh, what is a resource server? It's a server that is hosting our resource. In my case, Buffer is actually talking to Twitter API to schedule a tweet or read by Twitter timeline. So Twitter API is the resource server which Buffer is trying to access. Who is a client here? The client is the application which is trying to access the protected resource on behalf of the user. So in our case, what we are talking about is a Buffer. So the clients can be a public client, which can be accessed via the from the browser, which can only be accessed from the browser. And there are another type of client called confidential client. I will explain in detail about what these two different types of clients. What is an authorization server? The server which issues this token. So when I log into Twitter, when the authentication is successful, so Twitter gives back some kind of an access credentials back to the Buffer application. So in this case, Twitter OAuth server is the authorization server. So I'm going to go to the Jamboard. I'll show you some how the developer journey would have looked like. Let's say, okay. So okay, let me clear this up. Okay, so what happens is, like, let's say I wanted to create a new app called Twitter, which is like a clone of Buffer. So this is my application. So I'm the who is the developer. So I'm planning to create as a Node.js or a Spring Boot web application. So what I do is, like, I go to Twitter entity server and then say, hey, I'm creating an application. So I wanted some. I'm going to give saying that a schedule tweet. So I have to ask user to schedule it. So what happens is, like, Twitter will give me client ID and client secret. So I'll get this first step as client ID and client secret. After this, I'm ready to launch my application. So when the user uses my application, and then let's say click on schedule tweet button. So what happens is, I'll redirect the user to the Twitter API, like how we did for uh, our Buffer application, right? So I'll redirect to twitter.com OAuth server. Okay, I have to make this change. This is called authorization server, because that's the one which is going to give us token. So what happens is, like, I'll redirect the user and then I'll send them to Twitter authorization server. Hey, user, can you get me authorization from this server? So when I send this information, I just wanted to inform Twitter saying that this request is coming from my application. So what I will normally do is, like, I'll send my client ID, and then give the redirect URL saying that, hey, after you authenticate this user and you got the credentials, you send me back the access token to this URL. And also, I'll say some other information, but let's say like the scope. Let's say I wanted to schedule a tweet, so I need some what are all the things that I wanted to do? I need the privilege. So what I'll do is, like, give me a scope. I'll define the scope here. So these are all the informations I'll send to authorization server. So what happens? Um, uh, when the user logs it, I mean, when the user lands here in this page, it collects all this information, and then shows a concerned page to the user, like how we saw, right? Say this so and so application buffer with this client ID is asking for some permission. So that is a defined in the scope parameter. And do you want to acknowledge this? So when they say user says yes, what happens is like so basically what happens when they send all this information, it also the Twitter application also requests me to say like, can you give me an auth code? I'm giving you all this value. Okay, so this is the request that the Twitter authorization server receives. So it resolves all this information. If everything checks out okay, and then Twitter authorization server will return back an auth code. So once the Twitter application receives the auth code, what happens is like everything is happening inside the browsers, which is a public channel. Everybody can see what is happening inside this network. Anybody can intercept this network. So this channel is like vulnerable to attack. So what happens is like my Twitter application, I prefer to get the token via the secure channel. So first I'm doing is like I'll get an authorization code, and then I'll set up a secure channel. And this time I'll send my client ID. I don't need a scope. I'll send the auth code which I received from the user. I'll send my client ID, and I'll also send my client secret, which is this. So let me put it here. So all these informations I have to send. So Twitter authorization service checks whether this is the auth code issued for this client ID, and if this is the client secret for this client ID, because we already established this information. We know that. So kind of authorization server authenticates our client. So it's fine to say that uh, authorization server authenticates the client. So why we need this step is like any client ID can be public, so anyone can get this ID. If you go to any application that is running on auth flow, if you go to view source, or if you can intercept their network data, we can get the client ID. This is a public ID like our email address, but client secret is like our password. So only the client ID and client secret combination proves that this is the genuine application. So if someone else listens to this public channel and then got hold of this auth code, they would not be able to get an make the second request in the secure channel to request access token. So since this is an access token, authorization server um, verifies all these credentials, and then thinks that it is a genuine request, and then it gives back the uh, token. So this is the only token which we needed to call the Twitter API. And then I'll say I post my API tweet, and then this is my access token. I received it, and then I put it. So finally, if it is successful, I might get some response from the resource server saying that, hey, your response is successful. Uh, so these are all the things which are happening in the background. So as I already explained that we have to I mean, we have to get the access token via a secure channel, or it should be like protected very carefully. Why we have to do this? Because what happens to our I'll show you how an API request looks like. So this is how the API request looks like for the Twitter. So you are actually adding the authorization header, then you're calling post request with this. If you look at this, this token is opaque, and this token does not say that this is the token given to buffer application or the Twitter application. All the API server needs is a token, and it will not know who is sending it and what time it is being issued, on none of this stuff. So when twitter.com receives this token, it just checks whether the token is valid. So if that token is valid, it will return the result. So there is a possibility that if someone is listening to all these uh, network traffic, can get hold of the token. Let's say there is an evil app, uh, I call evil app. and that listens to it. So it can grab the token and can directly make the request, and then resource server will respond back. So this is not desirable. So we have to make sure that the token does not fall into the wrong hands. So let me delete this. So this is the normal developer journey in a web application, but there are other flow as well. Let me explain that. So yeah, so the application registers with authorization server to get client ID and secret, and then user initiate the authorization process, and then he gets a code, and then later the application establishes secure channel and then complete the authorization process. So at the end of the process, the application, our client, will get an access token, and that is the super powerful token. Um, so this is an opaque token. This is how the rest looks like. So what is an OAuth grant flow? Grant flows are ways of retrieving an access token. So what we have seen in a current example is like, one example is like, we used for a web application, right? But it's not all web applications are same. What if you don't have a dedicated backend to establish a secure channel? How else you can safely get your token? And what is happening in our mobile apps, like our Android and iOS apps? And let's say there are applications that are only machine to machine. How this access token is retrieved for these kinds of applications? So one such application which I mentioned is the authorization code grant flow. It means like you're actually exchanging your code to get a token. So in our case, we have a secure web application. Let us say that I don't have a secure web application. This is a single page app. All our Angular and Vue.js application executes inside the browser. This is not the safe place to put your client secret. And also, earlier browsers cannot make an authorization call to a different domain, because like, let's say my domain is called www.twitter.com, and then or buffer.com. So and I have to make a authorization call to twitter.com/auth. These two are different domains. So earlier browsers will not allow you to establish a secure channel in the browser. So in that case, what OAuth suggests is all you have is a public channel, so you can directly get an access token directly from this channel. But the vulnerability is still there. So we have to mitigate it from our application, making sure that we have a short-lived access token, or we have to take extraordinary measures. Usually, OAuth suggests not to go with this flow. And if you look at auth.net, they actually made it legacy. So, so they made the implicit flow legacy. Getting an access token directly via the browser is not acceptable. So I just have to explain this so that I can set the stage for the next. So if this is not accepted, how else they can solve this problem? So let's say I have a single page application, and uh, this is possible in our new browser's capabilities. So what happens is, if you have updated your proper CORS policy, content origin resource policy, you can make a post call to authorization server, meaning you can establish a secure channel now. So it's possible you can exchange your code for token. But when you have to exchange a code for token in our code grant flow, if you look at it, I have to send my client secret. But in this case, I don't have a secret because it's a single page app. Someone can get my secret here. When I register the application, normally I get a client ID and secret, but it's not good to put it in the code. Anybody can click on view source and get your secret, and then your application is compromised. So in these kind of applications, OAuth came up with a dynamic secret. Uh, what we have to do is like the application, when the user requests for to launch the application, what it does is like it creates a dynamic secret called creates a random string, and then it creates a hash of the random string called code challenge. So when it has to exchange it for the it's a usual flow. So normally I have to send my client ID, and then I'll define my scope. and then I'll request for auth code. So this is not a secure channel, this is a public channel. And then I'll request for code. Again, I have to define scope here. Um, so this time what I have to do, I'll just request the authorization server. And then what I'll do, I'll send my code challenge here over this. So what happens, authorization server will keep a copy of this token against my client ID. Let me keep the secret here. So it keeps like this is the client ID and this is the code challenge sent by the application. So what it happens is like it just stores here and then it gives the to code. So the application receives this code. Now the second step is to establish a secure channel. So from the browser, what I can do, like I can make a post call. So my secure channel is established. So I can send the random string now, and then I have to send my client ID. And this time I'll ask for access token. Hey, can you give me the access token? What it does is like I have to send the auth code, which is sent by the during the first transaction. So what authorization server does is like it will just match make to check whether this is the auth code given by me, and this is the it creates the code hash of the code verifier. Let me remove this. So it creates a hash of this code verifier, and then it matches with this. If everything checks out okay, then it sends the access token back in the application. So yeah, so we have received this access token and all it doing this is a received token. So we have to exercise like multiple, we have to exercise caution whenever we get the token so that it is not compromised. So that's why I have to go to this many lengths to get this token. And OAuth to stands is decided that since the dynamic secret is way better than the static secret, now they are actually recommending to use instead of auth code grant, ask them to use PKCE, which is called PKCE, proof code for code exchange, where you have a dynamic secret. So even if your secret is compromised, if some reason, this is a dynamic string, so no one can get hold of this. No one can decrypt this value. So this provides a safety alternative. um, but since it is recently recommended, normally we can see like few applications are using authorization code grant, but they are for any new application they are recommending to use pixie. So there is one type of application left, which I'm going to talk about. The other is called client credentials. Client credentials are machine to machine applications. There are no external user involved. There is no browser. Every channel is secure. So this is the easiest authorization code flow. So what it can do is like I'm already safe and sound here in this infrastructure. I'm in secure environment. So I don't have to go to the lens to change my token and exchange because channels are not the channels are public, but here this channel is also secure and this channel is also secure. So what happens is like the client application, let's say a buffer for example here, um, registers with this application. It has a client ID and client secret. So when it requests for it can directly put the client ID and client secret and ask for the access token directly. It doesn't have to wait. And this is different from implicit flow. In implicit flow, the channel is not secure, it's a public channel. So I can directly give the access token, sorry, request the access token, and then my client ID and client secret is validated with the backend, and then directly my access token is given. So I can make calls with the access token to this server, and then it can get my results. So these are all the different OAuth flows. So that's why it says like just because client credentials is very easy, we cannot just go and use it in the web application because you have to expose your client ID and client secret, and someone can take this application, and you have to, yeah, you will make your application vulnerable. Also, in single page application, you don't. Let's say you try to do a code grant flow, which I mentioned. We have to establish a secure channel to post our client secret. But in single page application, if you don't have, I mean, if you even if you can establish a secure channel via post, but you're actually sending a client secret which is stored inside your code base, which is visible to the user. So someone clicks on view source, you're exposing the client secret. So when you have to choose the web application, or when you have to choose the OAuth grant flow for the web application, it's not like choosing which one is better, which one is easier to do. It's like which application I'm developing, and then what is the recommended authorization flow. So it's like already one to one. So this is what we have seen so far. Authorization code flow with PKCE. All the transactions are given in one chart. So I have to generate my PKCE verifier, and then I'm getting redirected back. I'm calling an authorization a token, and I get I authorize the endpoint, and I want to get a code, and then the user consents to it, and then gives a response. So once I receive this authorization code, I'm sending back the authorization code to the token endpoint. So here it does not mention whether it is a secure channel or public channel. So I have to draw it in the Jamboard. So I get an access token, and normally when we get access token, we'll also get a refresh token. Why? Because like since the user is already authorized it, the access tokens are normally short-lived. Maybe depends on the application, but normally 10 or 15 minutes, for example. So normally when it is expiring, we can send a refresh token to get a new token. So we don't have to go through again asking the user to consent it. But that depends. If you want your application to force the user to consent again, then you don't need it. You can ask them to go through to the same code flow, asking for the consent. But usually where applications don't want any friction, so they go for refresh token, and then you get the response. So client credentials, as I mentioned, that it's a secure application. So you directly send the client ID and secret and get your token, and then you request resource with the token, and then you get the response. This is simple and easy. So this is kind of a cheat sheet. The applications recommended for the auth flow, the recommended authorization flows. But sometimes we might see applications using only authorization code flow without PKCE, which is still fine. It's just that it has an improved security. And single page application earlier was using implicit flow. For example, I can show you. If I go to medium.com, I have an so I have a plugin extension. So actually, they are directly getting the access token here. Um, which is not desirable, but Medium is still using this access token there. So if someone can grab this token, they can impersonate us. So yeah, so there might be some applications which are still using this flow, uh, possibly because earlier we don't have any option, so maybe they have to migrate it. And sometimes they would have taken a mitigation measure inside the application so that the code flow is not the bearer token or the access token is not compromised. iOS and Android applications are similar to single page application because they don't have a secure backend. So everything, the code is entirely downloaded inside your mobile. So someone can decompile the code. So it's not the safe place to store your secret. So normally we can treat iOS application as a single page application. So whatever is applicable for this is applicable for native iOS and Android application. Machine to application is the client credential. So let me show you a demo before we go to OpenID Connect. I already have an application running. Let's say I want to show there is an implicit flow. I'll show you how it works. Okay, let me sign in with Twitter. I click on the application. Since I'm already logged in, it doesn't ask me for the authorization. So this is what the access token I received from the transaction. Basically, I took all the values from the URL and I put it here. So imagine the access token is living here and it is synced in your browser history. So any application or any extension that is running inside the browser can get this token. So this is vulnerable. So that's why OAuth suggests not to use this flow. Let me go to implicit flow. Sorry, PKCE. In PKCE, I mean, eventually what you see is the access token. I'm signing in with Twitter. Okay, this is the access token. I don't have it in the URL, and I can show you in the code. Uh, Okay, so if it is an implicit flow, it's a single page application. So all the entire credentials and everything has to be stored here. So what happens is like this is my configuration. So I'm not storing my client secret here because this is a JavaScript application. So I just store my client ID, and these are all the endpoints I have. And then let me see what an implicit flow will look like. If if I have to click on implicit flow button, mm, yeah, this is the implicit flow. So I have to call the authorization endpoint, and I have to directly request for the token. This is what I mentioned. I don't request for code because I can't exchange it in the implicit flow. So I have to send my client ID, and then I have a defined scope. What is the scope I wanted this uh, my application to act on behalf of the user? And then redirect URI is the one which I mentioned. Like if after I gave my URL, after I redirect the user, I wanted the authorization server to return back to my application. This is very important because someone can intercept it, and then they can receive the access token. So what happens is like you have to normally register what are all the redirect URLs with your authorization server. So if it sees any cryptic URL that is not listed with it, so what happens is like it will just say like invalid access. You can try this in your when you're trying to application, like register a redirect URL and then try to give a different URL. It will just say like invalid redirect URL and then reject it. Then I'm requesting in the form of a fragment. That's why when I received this, I received everything in the URL fragment here in the implicit flow. So this is a fragment. So I receive everything in the fragment. Let's say what happens with the PKCE code flow. So this is what PKCE code flow starts. So as mentioned, I have to generate a random string. I call that as a code verifier. And then I have to create a hash of that. So I'm generating the hash, and I call it code challenge. So what I do is like this is going in a public, going in the native way. So what happens is like going via the browser. So what happens? I'm setting the endpoint, and now I'm not asking for token. This time I'm asking for code because I know there is a secure way I can access this. So I get a client ID with a scope. All those things are additional, which you will know why it is. You can read later on about it. What is the state and what is the redirect URL scope. So I am sending the code challenge here. This is the algorithm which I used to create the code challenge. Um, so I post this, I redirect this URL to the authorization server. Let's say the authorization server responds with a code. What happens? Let me show you. So this is the how the authorization server is returning the code. So what happens is like I'm sending the post request. So this time I'm posting the authorization code. I mean, I'm sending the authorization code, and then I'm getting the URL. So what happens after this has been successfully posted? I get my access token here. So this is the PKCE flow. Um, uh, the other one is the client credentials. Let me run my application. So client credentials is very simple. View terminal. So in my current credentials, it's a secure application. I don't need to run in the backend. So what I'm going to do is like in the header, I'm going to call it directly the token endpoint. I'm going to give my client ID and client secret. You're not supposed to share it. I'll delete this application anyway, so it's okay. I'll say node source index.js. So if you look at it, I get the access token directly. So I don't have to make any exchange or any token here. So I think that's it. We covered for the authorization code flows. Authorization flows for the OAuth 2.0. And that leaves us to OpenID Connect. So as I mentioned, OpenID Connect is like when you log into an application and sign in with Google or Facebook, then your identity information is shared across the applications. The one thing to note here is like when we looked at exchanging the data between these applications, what we got in OAuth 2.0 is like an opaque token. It does not mean anything. And let me go here. So basically, when something happens, when the authorization, when the application receives this token, it will not try to interpret this. It will just put it here and then access it. Whereas the token which receive in the OpenID flow is an ID token. So I can uh, get the token and then I can encode it. I mean, I can decode this information and then I can use it. So for example, let's say this Medium website, and then let's say I get started and say I am going to sign up with Google. Choosing some dummy account. So what happens is Google got that information. After successfully registered and authenticated in Google, it passed these two information to Medium. So it passes my name, what is already stored there, and then it passes my email address. So once I say create account, Medium get to know what this information which is passed by Google. So kind of not sure whether this is, let's say this is the token that has been passed by Google, which is in JWT format. So this is the information that has been sent, and the application Medium tries to decode this information, and then it finds what's my name and then my email address, and that's how it displays it in the account. So we know that the exchange happens is being understood by the application. So we'll take the same scenario, what happens with OpenID Connect. Sorry. Okay. So what happens here is like I don't have in OpenID transaction we have only two parties available. So what we call them as ID provider or Twitter ID provider, and this is a relying application. So let's see. So yeah, which I mentioned here, right? Visitors request the application to start the authentication process. The application redirects the visitors to Google, and Google redirects the visitors back to the application with the profile. And the application shows like, hey, welcome blog, so and so. So these are all the two parties available. One is the ID provider and this is the relying party. But ID provider is the same as the Auth2 server. Like in our case, Google, or we can still use Twitter for that. So this is capable of authenticating and passing the profile information. The relying party is a one that requests the data from OpenID provider. So here in this case, a Medium. So let's look at the developer journey. This is going to look a lot like Auth2.flow journey. The only difference is like instead of asking for an access token here, in all the transactions, it will ask for ID token. It's the same when it will normally request for code, and then when it receives this information, then it asks for ID token. So this is an ID token, and this token is not being passed across any channel. This token is used by the application itself and to identify this information. So there is no this happening here. So only the communication is happening between here, and we call this as identity server. So what are the OAuth 2 flows that are available? It's available for OpenID Connect as well, because it's the same flow. It's just that when you request for, when you exchange code for token, for example, we also ask for ID token. Let me pull you a great example. I think you have already seen this, but I'm just showing it again. Um, Okay, so I didn't put it here, but because this is the ID token, if you look at it. So I already requested for ID token inside the same application, and apart from access token in the implicit flow. And also, let's see the PKCE flow. In addition to getting the access token, I wanted to get ID token as well. But if you look at this application, I can decode this information. See, this is the test and test.com, the ID token which I requested for. The same thing, the code, I can show you how I request for it. Okay, this is the index.js, sorry. Let me get the token. So this is the response ID. So if you look at it, this token means that I want an access token, but I can also, I am requesting for ID token just for the demo purpose. I am treating this application where I need both OpenID Connect and auth flows. But it's optional. I only need access token to call an API, then I don't need this ID token at all. Suppose like in a medium application, if it wants only ID information, doesn't have to get an access token. And I have another application I can show you. Since this is a a single page application, I don't have to put a client ID and client secret. But let's say I'm running this is running on Spring Boot. So let me see. So if I'm passing it, this is actually exchanging code grant. So it's like I'm logging in with sign in to the Twitter. And then let's say I go to get the profile information. I've already decoded this information and then I put it here. So in this transaction, you might see, you just see, let me get it here. So I'm sending a client ID and client secret, and then I'm requesting for OpenID profile. This is a code grant which I'm using, sending in the secure channel. It's one thing I just wanted to mention here is like there is something called claims, but let me see. The authorization code flow, implicit flow, and hybrid flow are the same as our auth 2.4 flow. So instead of getting a response type code, I can send ID token and token. But some applications, they still try to get ID token on the first request, because let's say you want to, they wanted to greet you first. Let's say, hi Pradeepa, and then do you want to schedule a tweet? So they wanted to show the profile information first. So normally that in that case they will just get code and ID token, and it's not that sensitive. It's like near public profile information, right? So it's still okay to pass those information. So they think like they can get an ID token first, and then only for the excess caution, only for the access token. Implicit flow, that so it's still valid if it is for your authentication flow. If you're just sending your profile information, it is still okay. So if you look at this medium, I'll show which I showed you. uh, they mention the value called claims. So this is the actual token, and then there is something called claims, which we saw here. So claims is nothing but a name value pair. So they classified claims as like a name claim, profile claim, and email claim. So based on that, whenever you request for a token, you can mention that in the scope. Usually the scope is not pretty clearly defined in OAuth flow, because that is like, I want to schedule a tweet, I wanted to post a tweet, I wanted to delete a tweet. So that scope is defined by the resource server. But these claims are in the OpenID Connect. They are pretty standard. So they have a predefined claims called OpenID profile and email claims. We can also have a custom claim, like if you want to have send some other name called full name, and then say prefix both first name and last name, and then together you can also send it. But if it is in a usually the ID token will not have any sensitive information. Okay, that presents. So this is the demo we have seen. So when we define this profile, then it has a set of name value pairs called attributes. So you can also have custom claims, which I mentioned, like you can concatenate both your first name and last name and then present it. Often people confuse between the providers and the roles. For example, let's say I wanted to access my Gmail. So I have to, Google should authorize me so that to access Gmail. In that case, authorization server and the resource server are both kind of same, like Google, right? So similarly, like if you want to paste in Facebook, then your authorization server and your resource servers are same. And Google can also authenticate you, like how we saw in Medium, right? So it can also authenticate the user and can send the your username and your profile information. So in this case, Google is acting as anti provider, as an authorization server, and also it has its own resource. There are sometimes where we don't want we don't have to have our own uh, authorization server. So normally you have seen applications using Okta or Auth0. So Auth0 can have as an authorization server, and then you can develop your custom API and then put an Auth0 authorization server in the front. So that's why when you saw in my demo, when I create test at desk.com, I'm actually using my custom API protected by Auth0. So these roles, I mean, the roles are defined, but there might be applications that are sharing, like Google can act as an ID provider and also an authorization server. So that might be confusing in the mid, I mean, when you start learning, but it's actually Google is having two roles. Like Facebook is having both as an ID server in the Open ID Connect protocol, and then as an authorization server when you want to authorize some application to post on your behalf. So I just want to state this, but so that it will be easy for you to understand further. So these are all the takeaways for the today's session. So we saw what is OAuth 2.0 is and how the grant types are based on different kinds of applications and the infrastructure. And then OpenID Connect came into picture. There is a reason why OpenID Connect was defined, because earlier people were using OAuth 2.0 to get the profile information rather than getting the token. So what they will do normally, they will get an authorization, and then they go to the resource server, or they go to the same authorization server to get the user info in point. So the standards team, they decided saying that this is not what OAuth 2.0 is defined. So let's define something called ID token, and then they started using this. So we also saw what is the difference between OAuth standard and OIDC, how OIDC is an extension of OAuth 2.0, and OIDC flows, and how the OIDC flows and OAuth 2.0 flows are the same. So I have a couple of references here. I find if you are starting now, you can use this OAuth playground, which I find it good. You can just click on, so let's say I'm going to use my Gmail API, for example. So I'm authorizing my Gmail API. Let's say I select my mail.com. So I wanted to access the Gmail. I'm picking my email ID. So this is a concern screen I get. So if you look at this, this is the auth code that has been generated. And if you want to look at it, what is the request that it is going, like OAuth flow and how the client ID is being passed and everything. So like how we defined, right, we exchange the authorization code for tokens. So we get the tokens, and if you can see that token is expiring in so and so time. And if you say auto refresh token, then it will create a new refresh token every time. So if you go here, yeah, we can say, yeah, it's done. And then I go to the next step and then say, okay, I wanted to see the list of possible operations. Let's say I want to get a label of the list of my emails or labels. Let's say I send the request. So this is the resource server request. It's going to gmail.googleapis.com. It puts this token which we retrieved in the previous step, and this is the response. So if you want to play around, you can use this. This is really interesting. You don't have to create a demo application. You can just play around. You can see how we can retrieve the different APIs. Jar.io is the ID token. Normally, I sent via the JSON Web Token format. So you can look at this. So OAuth 2 contains all the standards which I mentioned here. Um, this one. So yeah, if you have any questions, let me know.
Um, Thank you so much for sharing your knowledge about OAuth and OIDC. So, based on our comments, there's not much questions, but Ramadevi said that it was a good talk. So, yeah.
Thank you.
But I do have a question. If, for example, I want to convert my website to something that supports OAuth, how easy it is to convert it, and what configurations do I need to do in order to like implement OAuth and OIDC in my website?
Yeah. So basically, let's say you want to. I prefer. Okay, let's say for example, I wanted to support sign in with Google, for example. So what I have to do is like I have to go to developer.google.com, and then I have to register my application. I have to get a client ID and client secret. So that's my application that I'm going to launch. And then when the user registers, when the user is clicking on the sign in button, then I have to provision, let's say I'm developing a web application, I have a secure backend, then I pick the auth code, pixie flow. So what happens then, I define my application in such a way that I use the user to redirect a users mentioned in the pixie flow, and that's how I get the access token. So that's the OAuth flow for Google. Usually what happens is like, let's say I want to define signing with Google, Facebook, and everything together. So it's normally we have some applications called Okta and Auth0 which act as a hub. So what you can do is like, you can use Auth0 and then register all these applications separately, and then kind of give the client ID and secret inside the Auth0 environment. But then you can call all the OAuth flows via Auth0. So that's how you connect it. I hope it answers your question.
Yeah, yeah, thank you so much. So, um, if in case our viewers would have questions after this live stream, where can they connect with you if they have
Um,
additional
You
questions?
can reach me on Twitter, which is at Pradeepa, which I mentioned in the slide. I can also drop my slide in the Google comment, so you can reach out to me.
That wraps up our Women in Tech webinar for today. Thank you so much again, Pradeepa, and have a
Thank
great day
you.
ahead.
You too. Bye bye.
Bye bye.